So today we're going to talk about visualizing multidimensionality. Now, okay, those are two fairly long words, and so I'm sure it sounds a lot more scary than it's going to be. It's just looking at different plots and graphs, and there's some really powerful ways you can get these plots in R and RInStat and in many other softwares, statistical softwares out there. We're going to go through this just illustrating with R and RInStat, but please, as always, feel free to use whichever software you'd like to use. So to go through this, we're going to do the case study example of a change in Omani livelihoods over time. This was the survey that was run between a survey was given in 2007 and a follow-up in 2017, 2018, across those 2 years. And as a result, we saw how the farmers in 3 villages in Oman changed their perceptions and their kind of farming habits and things changed over that period. And there's a lot more information on that back in topic 1. So change in Omani livelihoods over time. We demonstrate the power of statistical software in this topic, taking as an example how statistical software can help visualize complex data, such as the Omani data. By employing multiple dimensions and layers, we can effectively represent and understand multiple variables within the data. In this context, we showcase the power of R or RInStat for this purpose. There's this great package in there called ggplot2, and that really helps you to visualize so much with your data so powerfully. As always, there's resources in the at the end of this topic. There's some resources, and that goes through on how to visualize and create these sorts of plots with R and RInStat. And if you don't want to use these 2 softwares, there's plenty of tools online, I'm sure, for the software of your choice. So let's do the initial data visualization. So we've taken our data and we're going to look at the number of livestock in 2007 and in 2018. Here we have a box plot to look at this. And back in topic 1, there is some stuff on interpreting different plots and on different box plots. But just briefly here, the box plot kind of shows that kind of spread of data, that it gives your maximum point, which is the point up here. So someone in 2018 said that they had basically over 100 livestock. It gives the minimum point, which means in 2018, someone said that the smallest number of livestock anyone had was just under 10. This is our lower quartile, our upper quartile, and this here is our median. So we can see in general, we can see that there's generally an increase in the average livestock owned by farmers from 2007 to 2018. When working with data, it's important to dig deeper into the plot. Fortunately, statistical software offers a seamless way to incorporate additional dimensions into visualizations, enabling us to delve deeper into the data and uncover hidden patterns. The first initial layer that we're going to add to our graphic is to layer the individual values on the box plot to further illustrate the measure of spread. So we had our box plot before, which was our initial layer here, which gave the kind of overall idea of the number of livestock in both of our farms, in both of our years, sorry, for each household. And now we've added on it this layer. Now this layer has dots, triangles, and squares. The dots here mean that this person, when they were asked, feels that in the future they will decrease animal numbers. The triangles are that in the future they will increase animal numbers, and the squares are that in the future the animal numbers will stay the same. We've used these different shapes to illustrate how the farmer answered the question of future of livestock farming in both years. And this shows whether the farm intended to decrease, increase, or keep the same number of livestock asked. So a higher proportion of individuals want to increase the animal numbers in 2018 than 2007. So what we mean by this is we can see a lot more triangles, because the triangles are representing increasing in our 2018 plot than in our 2007 plot. And obviously we can look into tables and proportions to really verify this. Pivot tables, for example, are a fantastic way to verify this, as seen in topic 2. So a natural question to ask is whether those who wanted to increase their livestock in 2007 had a larger livestock in 2018. In other words, those people that have a triangle in 2007, are they the people who then have a higher value in the 2018? I.e., is this triangle, is this household here, which in 2007, this household here had about 25 livestock, and they said that they want to increase. Did they increase? Are they the person up here at over 100? Or are they increased to around here at 50? That's roughly 50. The plot looks to us as if every household has increased their livestock, but is this the case? Well, we can draw a line on it. So now we've built up our third layer. This line is connecting individuals, or the households in 2007 are now linked with the households in 2018. So we can see, we pointed out this household here earlier, who said that they want to increase their animal numbers. And they had about 25. And we could see, if we follow their line across here, that they did manage to increase. And actually 10 years later, they had over 30, roughly about 32, I'd say. That's not, yes, roughly around 32. Maybe a bit more, maybe a bit less. So we could see, though, that not every individual increased their livestock from 2007 to 2018, including some who wanted to increase it. So, for example, we see that there is a line going down here. Our lines that are going down are our households that have not increased their livestock. Now we see at the end of this line here that they've said that they want to decrease in 2018. Presumably, therefore, they wanted to decrease in 2007, or they might have changed their mind. It might have been that initially they wanted to stay the same, and it looks like that it's a square, so it looks like that they wanted to stay the same. And then at some point in that 10-year period, they said, okay, now I want to decrease, and that's why they've decreased. One individual who responded in 2007 said that they had 16 animals. That's this one here. In 2007, they said they had 16 animals and they want their livestock to stay the same. So they've got a square here and it's at 16 animals. However, in 2018, this has skyrocketed, and they're the individual that's all the way up here and says that they now have 115 livestock. So something happened in that 10-year period and that person changed their mind. And not only that, but they've actually now are saying that they want to increase it still. We can add another layer. So now we can color it by the village. And by doing this, we can see how the different villages have changed to each other. Did one village tend to increase? Did one village tend to decrease? Questions like this. So in Keisha, which is our green line, all livestock increased from 2007 to 2018. Every single green line is higher in 28, leads to a value that's higher in 2018 than it was in 2007. So we can just look at this and see that region has increased their livestock in that 10-year period. Any farm who wanted to increase their livestock in 2007 successfully did by 2018. However, in our other two villages, which are coded in red and blue, we see that some individuals increase their livestock while others decrease their livestock. So just in particular, we can see that this red line here goes down, that one that we pointed out earlier, someone that now says that they still want to continue to decrease. We see that this red line here goes down, and that ends up as someone who says that they actually want to increase their animal numbers. Now, Is it that they initially wanted to decrease? Is it that at some point in this interim, in this 10-year period, they did want to decrease? Or is it that something happened that forced them to decrease? Is that why they want to increase, but they can't? In Keisha, every person has increased. This is a really interesting observation that we've managed to find here, because we can see that if we're going to measure success on the number of livestock, we could see that this village is doing very successfully in terms of livestock numbers. Overall, we can use powerful graphics to help illustrate the data or story further by use of plots and statistical software. So we can kind of see these different stories by using these plots. By employing these advanced visualization techniques, we can invest and dig deeper into the dynamics of the data, revealing trends and changes over the time period. This visualization allows the analyst to investigate the complex relationships within the Omani dataset in a relatively straightforward way. Creating these graphics is not as complicated as it looks, particularly using tools like our Instat. Again, as stated down in resources, there are some guides on how to create these sort of plots in our Instat, and we really invite you to have a look through them, and particularly through the quizzes in this section. Thank you.